Research paper scaffolding. Okay, so I've had a couple questions today at the end of class about the research paper scaffolding. If you are able to, Diana, thank you for turning on your video. If you are able to have video, please turn it on. It definitely helps us teaching. It's weird teaching to black screens. I have to get back into my COVID days, and it's very awkward, but so thank you for that. I think quite a few of you have still not turned this in. And so I just wanted to go over this again because this is more of a learning the tools type of assignment than writing a full-on research paper assignment, which is what I think a lot of you, it sounds like, have been a little worried about with this. When you're going through this module, you're going to go through and there's lots of tools that Dr. A put together for some other classes with AI and these modules. Like the Marlowe one is pretty cool. It's got a cool little theme and it's really just to help you start to think about how to create a research question, right? So some of you just, I don't even know what to where to start. You could throw anything in there. You could, I'm interested in how many of these feral cats that are outside of my house are eating all the local birds or whatever it is, right? You can just throw in anything and it kind of will help you work into creating a research question with that. And then you have other tools in there, which are ChatGPT and what Consensus and all these other tools that you can use for various ways in for this research scaffolding. And it's really, just to get 2 pages in remember this is even though it's data viz, it's your writing requirement. So we wanted to just jump in and get you writing. And learning kind of the basic framework of writing, which is the scaffolding aspect of it. But don't get too intimidated by the research paper, title of it. It's really just getting you acquainted with these tools, familiar with these tools, and then getting you writing in the type of format that we are going to be using for this class, and kind of the strategy behind that. And so it's 1 to 2 pages. We're not really grading you totally on like having perfect grammar and perfect sentences and all that stuff. It's really that you're understanding what a research question is, how to break down the assignment. You have these clear headers, right? You're formatting everything correctly. And then you have these 10 peer-reviewed references. That might sound like a lot. And it is if you're right, if this was like you're reading through every single one. We don't expect you to just read every single 10 peer-reviewed articles. A lot of those tools that you're going through can help you get these articles quite quickly, right? Like once you build up a research question and you can put it in and say, hey, I need 10 peer-reviewed articles on this topic, right? You can ask it to summarize those. So you actually have an idea of what it is. So you're not reading 15, 20 pages of a document. And then you can use those to help you formulate a 1 to 2 page write-up for your assignment. So it's not supposed to be super crazy and intense. It's just to get you thinking in this format. So if there's any other questions, let us know. But there's a good chunk of you still haven't turned that assignment in. So we want to make sure that that's all working. You can figure out the modules and all the tools. Because next week we're going to be moving into our actual first manuscript project. And so we want to make sure that everybody's good with all this before we actually, shift gears. Dr. A, maybe you have something else to say about if I missed anything.
Yeah, and could you just click a couple pages forward in the module, Brenton, to the guide? I think it's
Previous.
next. I think it's next. I think yeah, go
Oh, I have all this chat stuff here.
and then one more. I
Next.
think maybe one more.
Yeah.
Or I guess
Yeah, here you go.
one more after this. This was the first week. This is the first time. We would hit the next one. Pretty please, the next page. Thank you. Yeah. So this is, you know, uh, this is pretty much says how to do this assignment step by step by step by step. So some people have come to me in the last week or so and said they really don't understand this. They don't understand what tools they're supposed to use. Again, I'm still a little confused because earlier pages walk you through turning on all these tools and exactly all the tools, introduce them, tell you a little about the background. This particular one, hopefully will be a useful tool for you to go through and how you can use these tools in writing. Again, you do not have to use these tools after this assignment. We wanted to give you guys options. We wanted to help you all that might have some anxiety or are not used to writing, doing technical presentations. This was really crafted to spoon feed you guys going through the process. And it's week 4, and I'm still a little bit confused as to why some folks aren't able to make it through this. So would love to hear, I'll pop around and talk to folks maybe individually today, but love to hear if there's, if, this module, which has worked for other classes, we've used this in several other formats and stuff, and people have historically told me this is extremely helpful and is appreciative. But I'm a little bit confused as to where how people are saying they don't know how to use these tools and stuff like that. So love for you guys to give me some feedback as to how you would like for example, this particular step-by-step how-to, what's confusing about it and how we can improve it to help add greater clarity for you. But again, this is, and after this assignment, you guys do not have to use any of these tools if you find them not helpful, not conducive to your writing process. By no means are we requiring you to do this. We just wanted to make sure you guys all had access to these options to facilitate to make it easier for you guys to do your stuff. So yeah, thank you. And while Brenton's doing that, I also hope everybody's staying safe. It looks like there's a couple surface flows going on in places like Palisades and stuff like that. And so we hope everybody is staying safe. The good news is that the storm does seem to be going through a little bit faster than we had previously forecast. So it looks like maybe a good chunk of the problematic rains have come down. So we're really hoping everybody is in a warm, snug place right now.
Is there any feedback? I know someone said that Marlo's hilarious, which yes, Marlo's quite hilarious. It's quite fun to work
You're
with.
welcome.
Yeah.
I hadn't heard hilarious before, so good. Yeah, excellent. I've heard a lot of comments about it, not hilarious.
Well, so try this out and hope, I mean, the goal too is a lot of these tools will help you with other classes, right? Because finding peer-reviewed article, these are some of the really great things that have come from AI. There's so many different papers now and all these different topics. It takes a lot of time to go through Google Scholar and some of the search engines through the library and type everything out. Then you have to click on everything. You kind of have to read through it. I'm not sure. Okay, like this helps you generate a lot of references really quick and can summarize it for you. So 10 peer-reviewed references aren't as scary. You could probably do 10 as fast as you probably get like 3 before with non-AI type of tools. So all right, well, let us know if there's any other I think folks, you just check this on this page only. Yeah, okay, thanks, Cal. Yeah, I think that's true. Cool. So where do we want to start, Dr. A?
Maybe we can uh, uh, one quick comment, and then maybe we'll turn it over to Brenton to maybe introduce the Pollinator data set, since we haven't talked about that yet. But one thing, in talking to some students in the last couple days that have I've given some feedback on and stuff. One thing I didn't really mention before, but just as a thought, recall one of the additional element that most of what you're doing this week is the same thing as we did last week, right? You're doing your summary stats, you're checking out the data, all that kind of stuff, making some visualizations. But we did add an additional um, ask of you for this assignment, and that is to tell us what you changed, right? So, I discovered that blah, blah, blah was problematic with the data set. So I fixed that. And then I noticed that this other kind of problem I observed in the data set, and I had to respond to that. So that's, we want to hear that. And while of course you guys are all saving your initial copy of the data as best practice, and then you're doing your edited version, you're saving that as like, V1 or V2 or however you're appending the name of the file. And so that's great. So you could always like turn one on when you're done and turn the original one and kind of go back and eyeball it. But that might be a little bit hard. So one suggestion made to several students was to think about inserting a column just to the right of your, or to the left of your variable that you noticed there was an issue in, and that maybe even like color coding the cell as something I want to change or whatever. And then as you go forward, you can change it in that one column, but not the other. And that might give you a frame of reference. So that might be a lot easier for you when it gets to the time of changing it. Of course, you could be keeping notes as you go, but that might be, um, uh, you know, and that's keeping notes as you go is a great way to do it. But having like a copy of the unchanged right next to the changed might be also a pretty slick way to do that. So you might consider that if you are still working on data cleaning.
Cool. All right. So I think we're going to continue on with, were there any questions about the price gouging data set before we go into pollinators?
Yes,
Yeah.
I was gonna ask, are we using arcsign for proportional values? Or because I remember we did that in class, but I remember it came up a lot of invalid numbers. Um, I didn't know if that was just a test, or like are we using that in their data?
No, it wasn't a test. It was just to show you guys. Some people asked how to do it, so we were just showing you guys how you'd go about doing it. Again, remember so it turns out that the data wasn't all proportional, right? The data was meaning it wasn't all between 1 and 0. And so because the data is different from that, the arc sign transformation isn't the most appropriate thing. And there were many, wasn't just one or two instances where the data wasn't proportional. There was, I forget, you guys can tell me, but like 20, 30, something like that.
Mm,
And so therefore that doesn't help the problem. Um,
got you.
but wanted to show you guys how to do that. Certainly well, I'll let Professor Speeds talk about the pollinator set, but you definitely will be needing to do arc sign transformation and log transformation as we go forward in the semester.
Okay, yeah, sorry, I didn't mean to say like it was a test, like, but I was just like, I didn't know if we were just
Yeah.
testing out a factor. Okay, cool, no worries, thank you.
Mm-hmm.
Cool. All right. So pollinator data. This is a messy data sheet. This is what happens when you have students have joint Google or shared Google Sheets, and they all put in data from a field trip.
What could go wrong? What could go wrong?
Yeah. So this is a field trip that some of you are in field methods or have taken field methods before. We work with the National Park Service at Satwiwa, Rancho Sierra Vista, to do pollinator surveys. We've been doing that with them for, I think, 6 years now. And so if you're not familiar with Satwiwa, this is campus, right? So there's our building, Sierra Hall, right? And if you just go through Potrero Road, you go over here to Satwiwa, and this is a national recreation area over here. So this is all run by the National Park Service. And so we have, there's some restoration sites over here. So like all of this area that looks like nice sage scrub habitat has all been restored. It used to look like this, and they've restored it over here too. And so we do pollinator surveys in here. We do pollinator surveys out here in the grass, because this is like potential sites. And then we do pollinator surveys over here. This is a big slope. You can't really see it, but it's very, very steep slope. So we do, and this is all natural. So we have a natural habitat we have a invasive grassland, and then we have a restored area. And so that's what we have. Multiple sheets here. We actually have a capstone team this year that's compiling all the data together and making sense of it. So they're essentially doing like what you're going to learn in like this week or the past couple weeks. That's what most of their capstone has been. And so a lot of this going through, this is how we break up the times that we're out there. So we spend 2 weeks out there. Week 1, we just spend in the restoration site. So you can even see here, I tried to add an example so they know exactly what type of data to put in, right? So put in Rancho Sierra Vista, right? Transect numbers 1, 2, 3. So they did that, the dates. But you'll see as they start going through, even like here, right? Put lat long. Some of them didn't put any. The longitude always has a negative sign, so it tells you what hemisphere you're in. Some of them don't. This is I don't know what value that is. 1,185. So even with
Mars, must be on Mars.
Yeah, must be on Mars. So even with some guidance, right? A lot of these are not properly put into place, or properly. But basically, there's an AM and PM. PM's just afternoon. So these data sets are the same, but they're just same type of data, but they're just done at different times. And this is just pollinators, right? So a lot of it is just the sites. These are the transect numbers. These are the locations. A lot of it's just administrative type stuff, right? The names of whoever was the observers and the data recorders, the start time, end times, how long that they're going, temperature, all that stuff. But you can even see here, right? They have on their data sheet, they have categories to do this for like the start and wind end. So even here, it's actually it shouldn't be start and end. I don't know, that probably was added. But they had categories for what type of wind. So is it medium, is it light breeze, all that stuff, and some of them just put like 0 to 12. So I don't know what that is. There's a lot of data in here. Light breeze. So we have light breeze that's 2 different ways, right? Capital and not capital. So it's a lot of the similar things that we were going through last week, right? Here we have clear skies with the capital C and lowercase, and then someone put in sunny, which wasn't an option, but sunny I would assume is clear skies, so we would have to address that. And so a lot of this stuff is similar to what we were going through last week. The big thing here, what we're really interested in, is the type of pollinator species and what plants that they're associated with. And so what's happening with a lot of them is you're seeing that they're finding pollinators, so cabbage, white butterfly, cabbage, white butterfly, cabbage, white butterfly, but they're not putting any association. So was that a flyby? Was it not associated? If it's a flyby, they're supposed to put flyby. But who knows? A gnat, we have gnat spelt with just an N, not
no G
right?
here.
So you want to go through, and we'll just keep it the way that it is. Ladybugs, things like that, right? But you want some type of universal. This happens a lot with species data, right? So you could easily have cabbage white butterfly. Some people would call it cabbage moth, and white butterfly, all these different things. If it's not universal throughout this column, right, then those are all gonna be different species. And then for some of these, they added multiple ones, which, mustard, if it was associating with 2 different plants, they should have had 2 separate entries. It should have been white butterfly with mustard and then white butterfly with California blackberry. And then this one's super confusing because it says it was associated with a plant, but then it was also a flyover. So I'm not sure what that was, but it looks like they had 8 of them, which is quite a lot. So don't expect you to clean all of this up, but this is supposed to be an example to show you how messy a data sheet can be. And especially ones where we have joint classes, field trips, and you have multiple students that are filling this out. This is kind of what you're dealing with, right? Even though you're providing guidance, you're providing topics and things like that for them to put in, it can get quite messy. And so all the more reason to go through and start cleaning things up. One of the things here that we didn't have in the other one was count data. So we get this a lot with biological surveys, environmental surveys, counts, densities, species richness, things like that. And so that's probably going to be the one that most of you gravitate towards first, right? There's how many of something were there. In order to figure that out, right, you could probably create a pivot table, and you could, look at like species and count and stuff. But what you'll find is it's all over the place because initially you have a lot of these, you have gnat that's not spelled correctly. I wonder if there's gnat down here. You just have like regular moth. What type of moth is that? Is that a cabbage moth or a cabbage white butterfly? That we have gnat spelled correctly. Awesome. We have a hoover fly, not a hoverfly, a hoover fly.
The vacuum insect.
That's right. So, and then we were supposed to be out there, monitoring actual pollinator like insects, but it looks like someone put a hummingbird in there as well. So all of that is these separate times. While we're doing that, they're doing transects with vegetation, right? So the vegetation data is similar. You have a lot of the same kind of administrative type of data, start time, end time, who's recording at what sites. But then over here, you have the max and the min height of the vegetation. So a lot of times when you do vegetation, you'll do like percent coverage. So you might use transects or point counts and things like that. For this, we just went through each transect location. So you started with the 0, so that'd be 0 meters. And that's the example. So you started 0, you went to 1, 2, 3. And so every one you took a min and a max. So you can actually see how different these were, and then the average. And so with those data, you can probably, we don't really have proportions, but for both of this data and for the pollinator data, this is where we would do the log transformation if we were going to transform it. And so we want you to practice the log transformation again. Reminder, this is what I usually do. You could do something separately, but what I usually do when I'm doing transformations, and Dr. Ray showed this last week, is I will insert a column. I'll put it over here, insert. And so I have a column right next to it, and I'll put like count, and then I'll put, log +1. So I know that's the type of transformation I did. And we all did the arc sign. We can go through and redo the arc sign if folks don't remember the code. But for log, it's equals log. There's a few different ones that come up. You have log test, log norm distribution, all this stuff. You just need the regular log one. So log. And you're going to choose the cell. So we want this cell over here. And then remember, for all those, we want to do +1. Close that up, and then it'll do the log transformation. You can, if you wanted to, highlight this, and you can drag it if you want. I always do the quick, right? So once you do that and it recognizes the pattern just with one, you can double click and it'll fill it all in. I always want to go and double check though to make sure it's right. So if I click this one, if I click V9, then in the code it should be saying, or yeah, V9, it should be saying that I'm taking U9, the one that's right next to it, +1, right? And so it shows me that right there. I can't always double click this too, and just it'll show it highlighted as well. But just remember, when you do that, anything that you push after that is going to type it into the cell, so you'd want to push escape to go back. But now with all that data with counts, you could see, even just looking at the data, right? We have a lot of spread with this data. So you have some that are like 1, but some of these pollinators, right? There's 50 gnats. And that's with an N. 25 gnats are here, so it's very gnatty that day. Honeybees, 24, right? But then once you do that, so that might suggest, if you graphed it out, a skewed distribution, right? So you might have a lot of these gnats and honeybees pulling that normal distribution curve in one direction or another. But doing this log transformation, just see how much closer this data is to each other, right? So you don't have as drastic of variations with your mins and maxes. And so that's kind of what we're talking about, where it helps pull back to that normal distribution, and it makes it a little bit easier to run your statistics, or at least it gives you more power, so you meet the assumptions for normality.
Professor Spies, can you zoom in a little bit in the screen?
Yeah.
Thank you.
So again, for this one with the count data, you'll want to go through, and I think with this, right, we have like bee and honeybee and all that stuff. You can choose whatever one that you want to do. You could probably just do honeybee species like this. And then this is how I put in that log code, right? So it's equals log the cell to the whatever cell you're choosing to do log transformation. In this case, it's the one to the left of mine, so it's U, and then +1. And then if I click on any of these, right, it should show it up here as well, log U12 +1, right? So it should say that right here, log U12 +1. And so in this case, when we had the arc sign and we're doing proportions, and we kind of had some of those weird metrics because it was above 100%, so it wasn't proportional. We couldn't really do any stats, or we couldn't really, it wasn't really usable data if we included those. This is everything's been log transformed, right? We don't have any indications of any weird numbers. And so all of that kind of checks out. It's really just making sure that we have, this honeybee or everything over here is set up. If you are interested, you could see if there's, associations with some of these more with other plants. You could see already, just kind of looking at it, coyote brush comes up a lot, mustard comes up a lot. You don't have to do, so for the assignment, you don't have to go through all these tabs. You just make sure to let us know what tabs you're working in, and you could totally create a new sheet if you want to. And if you wanted to, maybe after this, Dr. A can go over the X, what's the video that you just did, the
XLOOKUP.
the XLOOKUP, yeah. That might be actually helpful for this data set too. But you could just get, pollinator surveys and then some of the veg survey data, and you could create a new worksheet if you wanted to. But just to let you know kind of what these data sheets, going through, if you wanted to do more interpretation, all of these from week 1 were in that restored area. So all of these kind of pollinators we found in week 1 were just here and just here across the road. So AM and PM were in the restored area. And you'll see this even just looking at the data, just with the numbers, you'll see a big variation. Lots of pollinators in here. That's the kind of the whole concept of restoration. You provide all these new plants, the native plants, and then you get the native pollinators coming through. And then week 2, this is when we survey the other 2 sites. So the AM ones are these week 2 AM is this grassland. You're not going to get much pollinators in there. Right? It's all kind of non-native vegetation. You'll probably see lots of grass as the associated species or weeds, and very little pollinators. What we usually compare to, and if you want to do like a cool comparative analysis, especially if you're into plants and pollinators, is the week 1, the restored area is supposed to look like week 2 PM surveys. Week 2 PM surveys, you can even see it here, right? We have a lot of the hoverflies and the gnats and the cabbage butterfly, which is invasive, but that's fine. Honeybees, lots of the same thing. This is supposed to be a natural habitat. So that's where we come over here, and that restoration site is supposed to look like this natural habitat over here. And so you'll probably see week 1 surveys look like week 2 PM, and you'll probably see that week 2 AM, the grasslands look totally different than everything. But it'll be cool to see that, you know, in some type of figure or something like that, which would be awesome. I see that there's some questions in the chat, so let me look at those.
Yeah,
Yeah,
I guess.
so yeah, so you could just work in one or two. You don't have to work in all 6. For sure, that's a lot of data. You could also just create your own worksheet too if you wanted to take some week 1 data and some week 2 data to compare. You could copy paste and kind of create your own worksheet if that's what you want to do. Whatever you want, but just let us know what worksheet that you're working in for your assignment.
Can I have one other option that might help folks sometimes with this kind of data?
Yep.
So on column S, for example, or T, but you know, whatever, we can pick S as the example. There is some different level of precision, right? So Professor Speed just said, "Hey, you guys go out and tell me your pollinators." And some people, you know, have it to, you know, the species or a parent species, and others have it as a broad type of organism, some ant, right? But they don't say what species of ant, right? And so this is a very common thing, right? Where either and sometimes you want to identify the critter, but maybe the sun was setting and you couldn't see the bird. So maybe sometimes you identified the bird to species, but then other times because the bird flew too fast or the sun was in your eyes or something, you knew it was a bird, but you didn't, or maybe even sort of the rough kind of bird, but you couldn't do the exact species identification. So in other words, there's different levels of precision in the data set. So one thing you can do is, as we said before, you never want to delete the original stuff, right? So you always want to keep that so you can go back and reference it. But you could make your own new variable, right? So you could insert your own column. And this could be this could be like family, or it could be insect type, or you know, whatever the data set is, right? And so that could be consistent, right? Or order or whatever it is. And so that could be a way for you to organize stuff, right? So you would essentially create a different category, a different coding of the data. And that might be more consistent. So that code, and sometimes you might make 2 or 3 or 4 different versions. So a classic example would be geography. Geography and taxonomy are the classic ones. They're the easiest, right? So instead of saying, so sometimes people said Camarillo, and sometimes people said Ventura County, right? And so which one? But we could make a column that's just counties, and we can make a column that's states, and so on and so forth. So that there's, at some level, you get to a consistent, an apples to apples comparison of taxonomy, location, whatever it is. And so you don't have to do that, but that's a pretty common thing of doing these binning. But in other words, just because you have one variable there, you might have multiple bins. You might have multiple ways of coding it. So doing a data cleaning or a pre-processing doesn't necessarily mean a one-to-one change. Sometimes it means a one-to-many change. And so that's an option if you were so interested. Right. There's like, so Professor Speeds are like all the flies, all the bees,
Yeah.
all the, hymenopterans or whatever the case may be.
So you could totally go through like this, right? And you can, anything that says butterfly, you could put butterfly, monarch, right? It just gets butterfly, cabbage butterfly. Um, Ladybugs, we all know that, but down here there's ladybug, that's one word. There's lady beetle somewhere down here, lady beetle. So, you could totally there's probably 15 to 20 different names in this column. You could easily just create another column like this and reduce that down to 6. Because even if you think about making a visual, right, and you want to make a column chart or whatever, like having 15 to 16 or 20 variables on the x-axis could get really cluttery, right? So you might want to reduce that down to 6 variables anyways, just so it's easier to read. And you can come up with something like this easily. So now you have a much easier way. You put it in a pivot table, and then you can just say like, what's the total count of this family? So butterflies, flies in general, beetles, whatever, and then it can sum up. So you could go to that count, and you can, instead of count, you choose sum, and then it'll just sum up everything for you. You could do the same thing with, you can also, like, this is where you can get really creative with pivot tables, right? So if you want to see this, but you could also organize it by the association. So the association of flies with certain plants. But you probably with these plants too, you'd want to come up with a similar thing. You have lots of names over here, so you'd probably want to do a different column over here, and at least have like the flyby or no association. And then a grass, you just say grass, right? Maybe you just do shrubs, right? And so anything that's a shrub is, whatever. A mustard would probably be, I don't know, you could put to no association, right? And so now you've kind of gone through all of these. Rome is a shrub. So now you have like 5 or 6 of these categories over here of types of species, 5 or 6 categories of plants, and you have a plant or a count. You could do some cool analysis with that. Very simple. And you can make sense fairly quickly of a really messy and complicated data set. So I think that it'll be interesting to see what you come up with, because that's only just on week 1 pollinator data. And if you did that, you could also do some comparative stuff, which is pretty cool. So kind of run with it. I'm interested to see what you come up with. Questions?
I just commented this question, but like in this data set, we can kind of scroll through and correct, or not correct, but like we can scroll through and like put like butterfly if it says cabbage butterfly or whatever. But if the data set is like larger, are we able to just like put like, oh, like in this column, if this word includes the word butterfly, count the amount of times it said that?
Yeah,
Yes,
totally.
and a tool we'll show you probably next week is called Open Refine. And right now, Kale, you'd have to say if it says, lowercase b u t t e r f l y, then put in capital B u t t r f, you have to be fairly specific like that. Or if it says, what was it? Or if it said, like, if you're trying to do again what Professor Spees just did, you have to say if BLACK space FLY, then put in FLY space SPP, right? So and you can totally do that. And this is a relatively, even though this looks messy, this is a relatively small data set. So you could do that, and it wouldn't take that long, but so you can do it. But you can imagine once we start to get into a more complex or a larger data set, that would just take, weeks maybe, right? And just take a long time. So we have some tools, and the one we'll show you is called Open Refine. And that's one that will will look at your data set and you might tell it, hey, anytime there's butterfly anywhere in here, um, with it, capital letters, lowercase letters, a space, not a space, that kind of stuff, make that butterfly, and it's a bit smarter, and it'll do a lot of that stuff. It'll sort of do that stuff for you, or it'll make suggestions. Hey, this one, you didn't tell me what to do for this one, but this one, I think maybe you want me to put butterfly. Do you want me to put butterfly? And you can go, yeah, and you can do some training like that. And then once it's done a couple of them, it'll go do your whole data set. So, so for now, for this one, this is more of a kind of individual change or do a find and replace. But regardless, even for that, a big complex data set, with using a tool like OpenRefine or one of these smarter, machine learning type of tools, you still want to do a little bit of this, exactly what we're doing here. You look through it and you kind of decide what would be, how it needs to be coded. And again, just as a reminder, we'll say it many, many times, but we see the data. First thing you guys should do, scroll over the top. Let me look at the variables. What are the units? What's this? What's that, right? And then up and down a little bit, get a little bit of a sense of what the variables look like. In the case of this one that we're talking about, which is the pollinator species, do scroll through that. Even if it's a data set with thousands and thousands of lines, spend a minute or two and do scroll through and give yourself a feel for what those variables are like. And then you could decide, yeah, so Professor Speed is using the find and replace, or just the Command F for the find, and then you can kick into the find and replace option if you so wish. And so just see like how he has this right here, you could do it one by one. It could go like the next nat, because he said find nat. And then you say replace it, and you go, okay. And that would be stepping through with the next or the previous buttons. The other option is the one that says find all or replace all, and then it would just do them all in one fell swoop. So all these things you have, a level of control. But we just want to make sure you guys are getting this. First, look at the data set. Look at it. Let's hug the data set. Let's put our arms around it. Let's get a sense of what it looks like before we jump into anything. And then as you start to get a sense of it, and look at what the variance is and the averages are, that will hopefully pull you into some thinking. Oh, I wonder, maybe I could do family level, or maybe I could do dates, or maybe I could do week 1 versus week 2. And once you start making those decisions, that will influence how you do some of your pre-processing, right? That'll influence you. Oh, I'll need a variable for that, or I'll need a variable for that codes it this way, that kind of stuff, if that helps. Let's see, the question is, if the data set is larger and we do want to generalize a species, is there a way to count the amount of words in a column? Like if, so the question is, count how many characters are in the cell? Is that the question?
Like count how many times like column S says the word butterfly, and then it'll say like, oh, it says butterfly 34 times, and then I'll put
Yes.
So you could I'll just do this, because it's easy. It says sunny and clear, right? So I could say equals, and then there's count if, and then you can put, you could click on it. I think if you do that, or you could do sunny.
I think you have to put the range in first, yeah, but then you can do that, yeah. The range
did I
in front
not
of
put
sunny,
the-
the
let's
range
see.
in front of sunny.
Oh yeah. So I put the range in, and then it's comma, and then I can put sunny, enter, open up put 2.
And you have to put it in quotes, yeah.
And why isn't it working? Sunny.
Maybe because there's a space between the comma and the first, yeah, there you go.
Nope. We'll get there. Oh, because the
No, it's something, I think there's something weird with the formula. It doesn't see it as a formula for some reason. Yeah, there you go.
count if range comma. Can I just do that? Nope.
I think it's not. It's like it's still having the equation in there for some reason. It's like it doesn't. It looks like it's not like executing it for some reason.
Those count, but there is this way. Okay, we'll figure it out. But you can say count if, and it'll basically count whatever you're asking it to count and whatever criteria that you want. So, it should be. Yeah, I'll figure this out. I'll let you know, Kel.
Thank you. I appreciate it.
Yeah. wasn't it
Oh,
right
oh,
there?
oh, oh, oh! I know. It's just count.
Is it just count?
Yeah, take the if out. Oh, no, I guess not. I guess
I
not.
think the count if. I think you need to do count if.
But I think so. Now it looks like it's seen the formula at least. So take the space out between the. Yeah.
Mm-mm.
Yes, it's not. It's not. So, well, I'll figure it out. I'll figure it out. I'll figure it out. Hold
Yeah,
on.
we'll figure it out, Kel. But there is a way that you could do that. Any other questions?
Variations? Yes, I actually had a question.
Mhm.
In regards to you were listing off categorizing all the insects as just a family species, is there a way you could do a sum function on the count, but specifically only for certain species? Like if you wanted, because obviously if someone labeled, the cabbage white butterfly, but put 5, they counted 5. So that's, you wouldn't use the count function on that because that would just give you 1. Because, but so would you do that? Like, how would you do that?
So you want to sum up all the cabbage white butterflies? Is that what you're saying?
Or you're showing how you would bin them into, like, instead of honeybee, other bees, like just the bee species, the bee family, butterfly
Uh-huh.
family, beetles. But then they have a listed count of how much the student documented.
Yeah.
Is there a way that you could sum up all the number of butterflies that were counted, all the number of bees that were counted, and so forth, just so you can like see like what was the total population observed at the site?
Sure. I mean, I think you'd want to go through and you would want to give some characterization for all this, right? So then you'd have butterfly, you'd have fly species or flies, right? And everything would have that ability. And then you can come through and you can sort through, you could go data sort, and then you can, sort by whatever with a ST, I think it was column T. And then you could do values, and then you could do like A to Z, okay. And then it would organize all those. So you'd have all the butterflies together, you'd have all the flies together. And then so then you could have your little you could have a summary statistic over here, and it could be butterfly sum, right? And so you could do equals sum, click that, and then you can come over here and butterflies are 1 through 5, right? So I could highlight those and then enter, right? So then it's going to sum up all of the butterflies. So that's one
Okay.
way that you could do that, but you'd have to organize everything first.
Okay, so you'd label everything, then you would sort them by
You could
letter,
sort them. Yep.
and then okay, that makes sense.
Yeah,
Thank
so that's
you.
one way to do it. Did you figure out the count if?
Yeah, for mine it worked on my little. So I think there was just something funky with the thing, but so I just put in an example formula for you guys. So the count if is case insensitive. So if we said lady beetle with a lowercase a and then dy, ADY beetle, or capital L ADY beetle, the count if will just look for the characters. It doesn't count if is insensitive. this example of this one would be an example of a formula that is case sensitive. And it says like some people have an option inside their routine to pick if you want sensitive or not, if you're using, I think, the formula insert menu option stuff. So yeah, but I think you guys get the idea. We're already an hour in, and so this is great. I think Professor Spees and I will start popping around and or maybe give you guys 5 minutes and then start popping around and seeing if you guys need help. But again, just to reiterate, we're putting our arms around this data set. We're take a glance at it. What might I want to do? And then take a minute, and we're serious about this, right? Do not rush this. Like, push the computer away for 5 minutes and just think, what might I be interested? Hey, I wonder if time 1 versus time 2 makes a difference. Hey, I wonder if the morning and the afternoon are similar. Hey, I wonder if the first year and the third year are, in the mornings are similar. Or maybe I'm interested in just the first data tab, and I want to know what's the relationship of plants to to pollinators, or what's the most dominant pollinator just overall, right? So do think about that for a minute. That we're serious about that. Don't just rush in, and because Professor Spees or I clicked a column that you have to do that column. You're more than welcome to, but don't feel constrained by that, right? Whatever you guys feel curious about, have some fun and do a little bit of exploring. Yeah, cool. I'm going to kill the recording since I think that was the main thing we want to talk to you guys, but we'll still be floating around and answering questions for you guys.